Okay, so hello everyone. Today I'll be demonstrating how we can use the Altair Rapidminer software in order to solve a particular data science problem. And the data science problem I have chosen here is detection of fraudulent cases in credit card transactions. So let's start off. So I'll quickly walk you through the agenda of today's presentation. So firstly, we'll be discussing the objective of this data science problem, what all problem we are trying to solve. Then we'll dive a bit deeper into the dataset that we have used, and also we'll view some results of some of the exploratory data analysis techniques involved after applying EDA on the current dataset. What all results did we infer? Then we'll skip to the most important part, which is predictive modeling. And here I'll be demonstrating how we can use the Altair Rapidminer software to do predictive modeling via two ways, which is the auto model as well as the process panel. So, talking about the objective of this project, so the objective of this project, as it is obvious from the title itself, is to leverage the power of artificial intelligence to identify and prevent fraudulent activities in credit card transactions. And this is a very common data science use case, which is oftenly utilized in various banks and other financial institutions. And since it's a classification problem wherein we have to classify all the credit card transactions into potential fraudulent or non-fraudulent cases, hence there are a lot of traditional machine learning algorithms already developed in order to solve this problem. However, these traditional machine learning algorithms do suffer from a drawback that the dataset obtained in these cases, firstly, they are not complete in themselves, and also extracting features from these datasets is quite a cumbersome task. Hence, we'll be using various deep learning methodologies, such as using some neural network architecture, in order to classify the transactions as potential fraudulent or non-fraudulent ones. So, talking a bit about the data, so this dataset firstly has been taken from Kaggle.com, and the dataset contains transactions made by credit cards in September 2013 by European cardholders. And another most important thing about this data set is that it is a highly imbalanced data set. What by imbalance means is one of the classes in the target variable, but the count of one of the classes is very low as compared to the count of the other classes. And this is the usual case with all data sets which involves frauds type of cases. So here we have only 492 fraud out of the total 2,84,807 transactions, and this accounts to only 0.172% of all the transactions. And talking about the variables, so we have 28 variables which are PCA transform variables, and there are two variables which have not been PCA transformed. These are time and amount. Okay, so I have also applied some EDA techniques wherein I have tried to visualize the class distribution and the amount, the distribution of the amount variable. So as it is obvious from the first law itself that this dataset is a highly imbalanced one, wherein the count of the not fraud class is way higher than the count of the fraudulent classes. And also in the amount distribution, you can see that the count of transactions with amount equal to zero is way higher. So this creates a suspicion in the mind of the data scientist that uh, how come so many transactions with zero amount are taking place. And also we can see that as the amount increases, the count of those particular amount transaction decreases steadily. Okay, so next we move to the data pre-processing step. So as we know that this is the most important and the first and the foremost step before we start building off any machine learning or deep learning model. And here for data pre-processing, we have used the auto cleansing tool of the Turbo Prep feature of Rapidminer Studio. So the steps in order to demonstrate this, I can show you that this is a turbo prep tab, and here I have already loaded the training data, and here we can clean the data. So the further steps are, so the first step is involved is define target variable. So this is the variable class in our case. Then the second variable is changing the data. Second step is changing the data types of the variables. So in our case, however, we do not need to change the data types of our variables since all variables are continuous in nature. Then we move on to the third step, which is handling numbers. So this feature allows us to perform either PCA or normalization. However, as I just mentioned that since all our features are already PCA transformed, barring two, which is time and amount, so we do not need to perform this step as well, and we can move forward with the further steps. Okay, so next we move forward towards predictive modeling using the auto model feature. So what's the first step in this? The first step, as it's pretty obvious, is importing the training data set. So here you can see in the attached screenshot, I'm attaching this train data in order to as a training data set for the auto model. Then the next step is transforming the data. So in transforming the data, the first thing is we have to specify the purpose of the project. Whether it's a prediction problem where you have to predict the value variable, or is it like clustering, or where you have to just divide your entire data set into a few clusters, or whether it is outlier detection where you have to detect outliers. Then the next step is specifying the target variable, which is the variable class in our case. And also, we have to just switch on this option of turning the problem into classification. Otherwise, RapidMiner will take it as a regression problem and will output continuous numbers between 0 and 1 as the predictions. However, here 0 and 1 are not actually continuous numbers, or they're categorical variables. Hence, we are switching on this turning into classification option. Okay, then the third step in transforming the data is removing the variables or variable selection. That is, removing those variables that are not required. So in our case, it is ATT1 index time. So these variables will not contribute in this feature or fraud detection. Hence, we are removing these variables. Step three is choosing the model to be used. So here we are using four different types of models. We are starting with the most simplest model, which is a knife based. Then we will be using logistic regression. Then we'll be moving towards some slightly complex models such as deep learning or neural network models, and then we'll move towards gradient boosted trees. So these are the results obtained, and I'll show you this in the Rapidminer Studio itself. So this is the Rapidminer Studio screen, and here we have this option of auto model. So all the previous steps I have shown you earlier only, and these are the results which I obtained. So here you can see this is the comparative explanation of all the four models, and this symbol indicates that deep learning models perform better than as compared to all other models. And here we can also see various performance metrics. So here we are comparing it on the basis of the area under the ROC curve, and this also indicates that deep learning model performs better than all the other models. We can also view the ROC curve, which is the receiver operational characteristic curve. This is basically a curve between the true positive and the false positive rate, and is an indication and in an indication, so whichever model has the highest area under the AUC curve and the ROC curve, that model is performs better than all the other models. Then at the same time, you can also view uh, the results of individual models, such as for knife base. You can see here we can view the distribution of both the classes of the variables. Then then comes this important part of the simulator model. So here we are able to input the values of the of each and every attributes, and we'll be able to see the prediction of that whether it belongs to the true class or the false class. So you can change the values of these variables, and correspondingly you will get these predictions. So for these set of values, it's saying that 94% chances are that this is a non-fraudulent transaction, whereas only 6% chances that it's a fraudulent transaction. Similarly, you can also view the performance for each and every model, and also the predictions for each and every model. Similarly, for logistic regression, here you can get to know what all weights are attached to each and every attribute. Then similarly, again, all the performance metrics as well as the predictions. For deep learning and the model description, you will get all sorts of model descriptions as which all what was the neural network architecture used, what was the mean square error obtained, root mean square obtained, R square value, area under the ROC curve, log loss, mean per class error, all sorts of description. Even the confusion matrix you can see here. Then also adding the gradient boosted trees, you can get all sorts of results. Then also you can see in this tab some general statistics of the dataset which you have obtained. So here you can see the distribution, and you will get to see all sorts of descriptive statistics of each and every variable. You can just move your cursor and you'll get to know also the descriptive statistics of your variable. So moving back to the presentation, so these were some of the results obtained. This was the ROC curves I just showed to you. So what all inference did we draw? So the first inference which we draw from this analysis, that the deep learning models are found to yield marginally better results than gradient boosted trees, naive Bayes, and logistic regression model. And this inference is was pretty obvious, and it's also because of the fact that we are having a highly imbalanced data set. So we this was expected that the traditional machine learning algorithms will not perform as better as much better as these deep learning models can perform. And also, since it's a highly imbalanced data set, hence we cannot use accuracy as a performance metric, since here the concept of accuracy paradox will come into picture. So we are judging the model, different models based on the area under the ROC curve, and we can also view the metrics which I just showed to you. And this is the confusion matrix. This is actually the performance matrix for the deep learning model, which was found to uh, provide better results than the rest of the models. And this was a simulator function which I just showed to you. So wherein you can just change, you can just play around with these attribute values, and it will give you which class do these values belong to. Okay, so this was one of the ways of how you can perform predictive modeling using the auto model feature. Next, we see how we can perform predictive modeling using the process panel. So here we look forward to model the credit card dataset using neural network architecture to predict potential fraudulent transaction. So again, here come the data pre-processing steps. And one more thing is that we are using neural network architecture, since now we know that it is performing better than all other traditional machine learning algorithms. Hence, we'll try to model this dataset using neural network architecture. So the data pre-processing step actually involves removing, first of all the duplicate values which are present in the data set, and also then we perform some variable selection where we try to remove some of the variables which do not contribute in the prediction of the fraudulent cases. And to perform these data and to perform these operations, we have several operators which we'll see in the next slide. So here comes the main part of the process of performing predictive modeling using process panel, which is first of all specifying the design. So all these boxes here specify various operators, and I have also mentioned the description of these operators. So I'll just go through it briefly. So retrieve credit card, it's basically retrieving the data set from your local repository into the process panel so that we can build a model upon it. Then we have the remove duplicates operator, which actually removes the duplicate values in order to just compress or reduce the size of a data set. Then select attributes, as it's obvious from its name, it's basically used for feature selection, wherein you try to remove some irrelevant or redundant features. Then set role, this actually changes the role of a certain variable. So with this set role variable, we are able to uh, just tell the model that the variable class in our dataset is our target variable, which you have to predict for the test data or some other data as well. Then this is a split data operator, which, as it's obvious from its name, is basically used to split the data into two or more than two subsets. Here we have splitting the data into two subsets, namely the training data and the test data. And from this connection, we are feeding this training data on the neural network so that our neural network model gets trained on the training data. And then this trained neural network model gets is uh, sent to this apply model operator along with the test data from this connection. And this apply model applies that trained neural network on the test data in order to obtain the predictions. And this performance variable is performance operator is basically to assess the performance of the trained neural network on the test data. And so after simulating this particular entire design, we'll be able to get the results. So here I have mentioned the description of all the operators which we have used. Okay, so I'll just demonstrate this on the Rapidminer Studio as well. So here were the designs. Each and every these are all the connections, which basically symbolizes the sequence in which these operations will run. And also you can view the a description of any operators here also, and as well as you can see the tutorial of how you will be using it, how you'll be using each and every operator. And these were some of the results obtained. So this was the accuracy 99.94%. However, as I just mentioned, that since it's a highly imbalanced data set and here accuracy paradox concept comes into picture. So if your model is saying that all the transactions are not fraudulent, still it will have very high accuracy. However, that will not be an ideal case. So here we'll be using some other performance metric in order to judge the model's performance. So classification error is a good metric for it, and here you can see that the classification error is pretty low. It's only 0.06%. So 0.06% of samples are only being classified incorrectly, and this is actually the confusion matrix where you are also able to view the class precision and class recall scores, which also are pretty high, which indicates that we are heading in the right direction. And also the correlation for this model obtained is 0.807. Then in the description tab you can see we have the performance vector, which again displays some of the other results, which is the accuracy, the confusion matrix, the classification matrix, and the correlations. So yeah, these are again I have attached the screenshots of the results obtained. So these were this was how we can use the process panel to uh, model or build our own machine learning or deep learning models on any data set and on any kind of data set and solve any particular data science problem. Okay, so that's it from my side. Thank you, and I hope you enjoyed the demonstration, and thank you for your patience.